Consider the linear homogeneous convection-diffusion equation in one dimension. du over dt equal to d times d2u over dx squared minus v du over dx. Here d and v are just numbers. Assumes a separated solution u equal to x times t, and the separation constant is minus lambda. We need to find the resulting ODE system. So let's separate the variable u xt equal to x times t. X is a function in x and t is a function in small t. And with that, we need to compute the partial derivative with respect to t and with respect to x. Du over dt is d over dt of x times t, which is x times t prime, because x is just a constant with respect to t. So when we bring x out, d over dt of t. This one is a function in t, so it is t prime. Similarly, you have du over dx, which is x prime times t. du d2u over dx squared is x double prime times t. And plug in this equation. We have this equation. du over dt. du over dt is x times t prime. X t prime equal to d times x double prime times t minus v times x prime times t. So now we want to separate x to one side and t to the other side. Let's copy that and divide both sides by x times t over xt over xt. On the left, we have x and x cancel out. On the right, you have t and t cancel out. You have t prime over t equal to d times x double prime over x minus v x prime over x. And they told us to use the separation constant minus lambda. So I let it be minus lambda. The first ODE is t prime equal to minus lambda t, and the second one is d times x double prime over x v x prime over x equal to minus lambda. This one is t prime plus lambda t 0. The second ODE is d x double prime v x prime plus lambda times x is 0. So here is the ODE system that we get after separation of variable. And this exercise only asks the resulting ODE system. You don't need to solve that.